Question says calculate the distance in longitudes. Okay, there was a mistake here. Okay, so just a moment. This is not supposed to be there. Okay, like this. Hope you're able to see. Alright, like this. Oh my god. Okay, so let's just make it be like that. There was an error or typing. Okay, alright. Okay, now we're good to go. So the question says calculate the distance in longitude between point X, which is 33 degrees north, and 70 degrees west, that is the longitude. Latitude is 33, and point Y, which is lying on the latitude 44 degrees north and 70 degrees west. So one thing you can note from here is that, in fact, we want to calculate this in nautical miles, and so once you hear this nautical miles, that means your R, your radius, you are going to use is 3437, right? If it was in kilometers, you use 6370, right? Cool. So 70 degrees west and 70 degrees west, this is telling you that the 2 points X and Y are lying on the same longitude but on different latitudes, and that's what you can see from the diagram. So this diagram you will not be given. You really need to interpret the information in the question and be able to draw one of diagrams like this one. So in the diagram, I have indicated where point Y and point X should be, and the latitudes, we have 44 degrees there and we have 33 degrees. They are both north, right? And 70 degrees right there, which is in the west. So to calculate the distance, the formula is given by X, right? The formula is given by XY is equal to theta over 360 multiplied by 2 pi r. R you have, that's in nautical miles, that's 3437. Now what is your theta? Remember, when you are calculating the distance along the longitude, the theta becomes the difference in the latitude. And when you are calculating the distance along the latitude, the opposite of this becomes true. Alright? So what will be the value of our theta? We have to find the difference in latitudes. So we have latitude 1, which is 44 degrees, that's north, plus we are adding, we are subtracting, because these two latitudes are both in the north, right? So we subtract. So we have 33 degrees north. Our difference, which will be the value of our theta, will be 11 degrees, right? Cool. Then we can continue. Our job here is just to substitute. So we have XY there. Our theta is 11. We divide that by 360. We multiply that by 2. And we multiply that by pi, which is 3.142. Then we multiply that by the radius, which is 3437. Now if you use your calculator, okay, you are going to get make sure you use your calculator and confirm this number, that's 0.188. Now this is not your answer. Remember, you have to divide this by 360, okay, which will finally give you the distance. Now according to the instruction, the final answer should have just 2 decimal places, right? So if we do that, our answer would just be that. So you write your answer according to the number of decimal places in the instructions. That's nautical miles. Alright, so this is how we solve the distance. We calculate the distance along the longitude. To calculate the distance along the latitude, maybe I can just help you with the formula, right? So along the latitude, I'll just put L to mean distance along the latitude. Well, the first part is still the same, right? So the first part is still the same. Now the only difference is that here you're going to multiply by cos you can put cos theta or cos x degrees. Now this x degrees represents the latitude at which 2 points are lying. Remember, when you are calculating the distance along the latitude, 2 points lie on the same latitude, right? And your theta becomes the difference in longitudes. That is when calculating the distance along the latitude. While calculating the distance along the longitude, theta becomes the difference in the latitudes. Very important to remember. We proceed to the next question. The second question says, if time at point P, you can see where point P is in my diagram, okay? So this diagram will not be given to you. You need to interpret the information in the question and be able to draw a diagram like this one. This becomes very easy because you will see where all points are. So this is point P lying on 30 degrees south, that is latitude, and longitude 20 degrees east. The time is 13 hours at this point, that's point P. Then we have point Q, which is lying on the latitude 12 degrees in north and 100 degrees west as its longitude. So I want to calculate time. Remember, 2 points lying in the same longitude or on the same longitude have same time, while 2 points lying on different longitudes have different times. If you want more explanation on how that happens, you can request for a video or for explanation. I'll be able to do that. Alright, so we want to find time. The first thing we do is to find the difference in longitudes. So we have PQ, the difference between P and Q in their longitudes. We have 100 degrees west, right? So we are going to add 20 degrees east because these 2 points lie in different directions. One is in the west, the other one is in the east. So we add. We are going to get 120 degrees as the difference in the longitudes between P and Q. Now, we know that the Earth rotates at 15 degrees per hour, right? Again, if you want more explanation on that one, you can request for it. I'll be able to explain to you how that comes about. So we have 15 degrees. The Earth rotates 15 degrees in just 1 hour, right? So if this is the case, we are saying the difference between these 2 points, P and Q, is 120. That's 120. So if the Earth rotates 15 degrees in 1 hour, what about 120 degrees? there we can solve for x. We're going to have x is equal to 120 degrees. That's, we have the hour, divide by 15 degrees, right? Now, if we do that, we are going to remain with hours, and we are going to find this to be 8 hours. So the difference in time between these 2 points is 8 hours. Now remember, point P is in the east, and the time is 13 hours, right? Now point Q, where we don't know the time, which we are calculating for, is in the west. So the time difference between these 2 points is 8 hours. That tells you what to do, right? That means the time at point Q, since it's in the west, we lose time and then we subtract, while in the east we gain time and we add. So in the west we have to subtract. That's 13 hours, right? Minus 0.8 hours. That's 8 hours. Okay, so that gives you 0.5 hours at point Q. That's the difference here. Okay, it's not the time, but the difference in time between point P and Q. So now point Q will be, the time at point Q will be 0.5 hours. So if the time at point P is 13 hours, the time at point Q is 0.5 hours. So this is how you answer all the questions, similar to the ones I've answered in this video.